3,500 years ago, a group of voyagers did something that should have been impossible. They crossed over 2,000 kilometers of open Pacific Ocean with no islands to rest on, no stepping stones, no safety net. They sailed further into the unknown than any humans before them, reaching a chain of tiny islands so remote that if they missed by even a few degrees, they would have sailed into endless ocean and died. But they didn't miss. They landed on the Mariana Islands and they became the Chamorro people, the first inhabitants of remote Oceania. And here's what makes their story so strange. According to everything we thought we knew about Pacific migration, they shouldn't have been there. The timeline doesn't work, the genetics don't match, the route doesn't make sense. For centuries, colonial historians tried to explain the Chamorros by fitting them into narratives that made sense to Europeans. But the Chamorros never quite fit. And when scientists finally sequenced ancient DNA from 2,200-year-old remains in 2022, they discovered something that rewrote Pacific history. The Chamorros weren't part of the Great Polynesian expansion. They weren't connected to the Melanesian cultures that dominated the Pacific. They were something else entirely. A people who made an impossible journey, survived in complete isolation for 2,000 years, and preserved a genetic and cultural identity so distinct that even genocide couldn't erase it. This is the Chamorro mystery, and it's a story colonial history couldn't explain. The Mariana Islands are a string of 15 volcanic and coral islands in the western Pacific, stretching over 500 kilometers from Guam in the south to the northern islands near Japan. They sit at the edge of remote Oceania, the vast expanse of Pacific islands that were among the last places on Earth to be reached by humans. Remote Oceania begins where Near Oceania ends, where the islands become so far apart that you can't see the next one from the last. Near Oceania, places like New Guinea, the Bismarcks, and the Solomons was settled 40,000 years ago by some of the earliest seafaring humans, but remote Oceania remained empty for tens of thousands of years because reaching it required technology, navigation skills, and sheer audacity that earlier peoples didn't have. The accepted model of Pacific settlement says that remote Oceania was colonized by the Lapita people, the ancestors of Polynesians. Starting around 3,000 years ago, they island hopped from the Bismarck through Vanuatu, Fiji, Tonga, and eventually to Samoa and beyond, carrying with them a distinctive pottery style, pigs, chickens, and a language family that would become Polynesian. But the Marianas don't fit this model. The first humans arrived in the Marianas around 3,500 years ago, before the Lapita expansion even began. And they didn't come from the Bismarcks or Melanesia. They came from somewhere else, following a route that left no archaeological trail, crossing an ocean gap that no one should have been able to cross with the technology available at the time. There are no islands between the Philippines and the Marianas. It's over 2,000 kilometers of open water. If you set out from the Philippines and sail east, you either hit the Marianas or you sail into the Pacific and die. There's no room for error, no chance to turn back. You're committed the moment you leave sight of land. So how did they do it? And more importantly, why? What drove a group of people to sail into the unknown, toward islands they couldn't have known existed, risking everything on a journey that could easily have ended in death? We don't know. There are no records. No oral tradition survived the later colonial catastrophes. But the fact that they succeeded, that they reached the Marianas and established a thriving civilization, means they were among the greatest navigators in human history. And once they arrived, they stayed. For nearly 2,000 years, the Chamorro people lived in complete isolation. No contact with the outside world, no trade, no migrations in or out. The Marianas became a time capsule, a place where a unique culture developed without influence from anywhere else. By the time Europeans arrived in the 16th century, the Chamorros had built a sophisticated society. They spoke a language called Chamorro, which belongs to the Western Malayo-Polynesian branch of the Austronesian language family. This is significant because it links them linguistically to the Philippines, Indonesia, and Taiwan, not to Polynesia or Melanesia. They organized themselves into matrilineal clans, where descent and inheritance pass through the mother's line. This is unusual in the Pacific, where many societies are patrilineal. They built latte stones, massive stone pillars topped with hemispherical caps, used as foundations for houses and possibly ceremonial structures. These are unique to the Marianas and don't appear anywhere else in the Pacific. And here's what's fascinating. Unlike almost every other population in remote Oceania, the Chamorros show no genetic connection to Papuans or Melanesians. Most Pacific Island populations, from Fiji to Hawaii, carry a mix of Asian and Papuan ancestry, because the Lapita people who settled those islands had already mixed with Papuan populations in near Oceania before expanding eastward. But the Chamorros are different. They bypassed near Oceania entirely, sailing directly from island Southeast Asia to the Marianas without stopping in New Guinea or the Bismarcks. This makes them genetically distinct from Polynesians, Micronesians, and Melanesians. They are pure island Southeast Asian in ancestry, with no Papuan component. And this wasn't confirmed until 2022, when scientists finally sequenced ancient DNA from pre-contact Chamorro remains. The breakthrough came from Ritidian beach cave on Guam, a site that had been known to archaeologists for decades but whose full significance wasn't understood until ancient DNA technology advanced enough to extract usable genetic material from tropical environments. In 2022, researchers successfully sequenced DNA from human remains dating to around 2,200 years ago, roughly 1,300 years after the initial settlement of the Marianas. This was a technical triumph because DNA degrades rapidly in hot, humid environments, and the Marianas are both. But the team managed to extract enough genetic material to compare the ancient Chamorros to modern populations across Asia and the Pacific. The results were definitive. The ancient Chamorros were most closely related to populations in the Philippines, particularly groups in the northern Philippines and Taiwan. They showed no Papuan ancestry, no connection to Melanesia, and no genetic relationship to the Lapita-descended Polynesians. This confirmed what linguists had suspected but couldn't prove. The Chamorros came directly from island Southeast Asia, likely from the Philippines, in a single migration around 3,500 years ago. And after that, they were isolated. No subsequent migrations reached the Marianas for nearly 2,000 years. The islands were too remote, too far off the main Pacific migration routes, and too difficult to reach by accident. But the most remarkable genetic finding wasn't in the nuclear DNA. It was in the mitochondrial DNA, the genetic material passed from mother to daughter across generations. When scientists analyzed mtDNA from both ancient and modern Chamorros, they found something extraordinary. Between 85% and 92% of Chamorros carry mitochondrial haplogroup E, a lineage that traces back to island Southeast Asia and is virtually absent in Polynesia and Melanesia. This is one of the most extreme examples of genetic continuity in the Pacific. Even after centuries of contact, colonization, and mixing with other populations, the maternal line remains overwhelmingly indigenous. And within haplogroup E, the Chamorros carry a specific subclade called the Chamorro motif, a unique variant of B4A1A1 that exists nowhere else on Earth. This motif is related to but distinct from the Polynesian motif, the mtDNA signature carried by Polynesians, proving that the Chamorros and Polynesians diverged before their respective migrations into the Pacific. The Chamorro motif is proof of long-term isolation. It arose after the initial settlement and was maintained through endogamy, marrying within the community, for thousands of years. This genetic isolation was reinforced by cultural practices. Chamorro society was organized into matrilineal clans where identity, status, and land rights were inherited through the mother. Women held significant social power, and the maternal line was a thread that held society together. This social structure had a biological consequence. Because identity was matrilineal, Chamorro women passed their lineage to their children even when they married outsiders. This pattern would become crucial later, during the catastrophic colonial period, because it meant that even when the population collapsed and paternal lineages were lost, the maternal line survived. The mothers who never left, who stayed on the islands and passed their mtDNA to their children, preserved the Chamorro genetic identity through centuries of upheaval. But that survival was not guaranteed. In 1668, Spanish missionaries arrived in the Marianas with a mission to convert the Chamorros to Christianity. What followed was one of the most devastating conflicts in Pacific history. The Spanish-Chamorro Wars lasted from 1668 to 1700, over 3 decades of brutal fighting, disease, and demographic collapse. The Chamorros resisted Spanish colonization fiercely, but they faced an enemy with guns, European diseases, and a determination to break their culture. The pre-contact Chamorro population is estimated to have been between 50,000 and 100,000 people. By 1710, fewer than 4,000 remained. Some estimates suggest the population fell as low as 1,000. This is a population reduction of over 95%, one of the most severe demographic collapses in recorded history. The causes were multiple: warfare, smallpox, influenza, forced relocations, and the destruction of traditional food systems. But the genetic consequences were just as severe. When a population crashes this dramatically, it experiences what geneticists call a bottleneck. Most genetic lineages are lost. Only the individuals who survive and reproduce pass their genes forward. This creates a founder effect in the next generation, where the genetic diversity of the population is determined by the random survivors of the catastrophe. For the Chamorros, this meant that many ancient lineages were lost forever. Y chromosome diversity collapsed as most men died in warfare or disease. Certain traits that were rare before the bottleneck became common afterward because the survivors happened to carry them, and the population became more vulnerable to genetic diseases because the loss of diversity meant harmful recessive traits could no longer be diluted by mixing. The Chamorros didn't just lose history, they nearly lost the future. The fact that they survived at all is a testament to resilience, but the scars of that catastrophe are still written in their DNA. And those scars became visible in the 20th century in one of the strangest medical mysteries in modern history. After the United States took control of Guam in 1898, American doctors began noticing something disturbing. Chamorros were developing a neurodegenerative disease at rates far higher than anywhere else on Earth. The disease had two forms: litico, which resembled amyotrophic lateral sclerosis, ALS, causing progressive paralysis, and bodig, which resembled Parkinson's disease, causing tremors and dementia. Together they were called litico-bodig, or ALS-PDC, ALS Parkinsonism Dementia Complex. At its peak in the 1950s, the rate of ALS-PDC in Guam was 50 to 100 times higher than the global average. Entire families were devastated. In some villages, multiple members of the same household developed the disease within years of each other. American neurologists were baffled. The initial assumption was that this was a genetic disease, an inherited mutation unique to the Chamorros, possibly amplified by the bottleneck effect from the Spanish Wars. But that theory didn't hold. If it were purely genetic, the disease should have remained constant or increased over time. Instead, the rate began to decline in the 1960s and 1970s. And even stranger, non-Chamorros living on Guam, including Filipino immigrants and American military personnel, began developing the disease, but only if they had lived on the island for many years and adopted traditional Chamorro lifestyle practices. This suggested an environmental cause, not a genetic one. The breakthrough came when researchers identified a neurotoxin called BMAA, beta-methylamino-L-alanine, in cycad seeds, a traditional food source used by Chamorros during times of scarcity, particularly after typhoons destroyed other crops. Cycad seeds contain high levels of BMAA, which accumulates in the brain and causes neurodegeneration. But here's the twist. Not everyone who ate cycad seeds developed the disease. This meant there was a gene-environment interaction. Certain individuals were genetically more susceptible to BMAA toxicity. The genetic bottleneck may have increased the frequency of susceptibility genes in the Chamorro population, making them more vulnerable when environmental conditions, food scarcity, reliance on cycad, triggered exposure to the toxin. In 2023, researchers made another breakthrough. They identified litico-bodig as a unique double prion disorder, involving two types of misfolded proteins that propagate through the brain. This discovery placed Guam at the center of global neuroscience research, as understanding this disease could provide insights into ALS, Parkinson's, and Alzheimer's. The Chamorro experience with litico-bodig is a stark example of how ancient genes, shaped by isolation and bottlenecks, can interact with modern or changing environments in unexpected and tragic ways. But it's not the only example. The same pattern appears in other health conditions affecting the Chamorro population today. Diabetes rates among Chamorros are exceptionally high, around 19.5%, nearly double the US national average. Gout, a painful inflammatory condition caused by high uric acid levels, affects an estimated 28.5% of Chamorro men, one of the highest rates in the world. These aren't random. They're linked to what geneticists call the thrifty genotype hypothesis. This idea, controversial but supported by evidence in Pacific populations, suggests that populations who experience cycles of feast and famine evolved genes that maximize energy storage during times of abundance. In a traditional subsistence environment, where food was unpredictable and starvation was a real threat, genes that promote fat storage and efficient metabolism were advantageous. They helped people survive. But in the modern world, where high-calorie processed foods are abundant and constant, those same genes become maladaptive. The body stores excess energy as fat, leading to obesity, insulin resistance, diabetes, and related metabolic diseases. For the Chamorros, this shift happened rapidly. After World War II, Guam became heavily Americanized. Traditional diets based on fish, taro, breadfruit, and coconut were replaced by imported processed foods: white rice, canned meat, sugary drinks, fast food. Within a single generation, the dietary environment changed completely, but the genes didn't. The genetic adaptations that helped Chamorros survive on islands with limited and variable food resources became liabilities in an environment of abundance. And the genetic bottleneck from the Spanish Wars may have amplified the frequency of these thrifty genes, making the modern health crisis even more severe. This is not unique to the Chamorros. Other Pacific Island populations, including native Hawaiians, Samoans, and Tongans, face similar health challenges for similar reasons. But the Chamorro case is particularly stark because the population was so small after the bottleneck, and the dietary transition was so abrupt. Now here's where I want you to think carefully, and I genuinely want to hear your perspective in the comments. The thrifty genotype hypothesis is widely used to explain high diabetes rates in indigenous populations, including Pacific Islanders, Native Americans, and others. But some researchers have criticized it, arguing that it places the blame on genetics rather than on the social and economic factors that actually drive health disparities. Poverty, food deserts, lack of access to healthcare, the legacy of colonialism that disrupted traditional food systems. If we say the Chamorros have high diabetes rates because of their genes, does that let colonial powers and modern governments off the hook for creating the conditions that caused the health crisis in the first place? Or is it simply acknowledging biological reality, that genes shaped by one environment don't always work well in another? This isn't a simple question. Some argue that focusing on genetic explanations stigmatizes indigenous populations and ignores the structural racism and economic inequality that are the real causes of health disparities. Others argue that ignoring genetics means we miss opportunities for targeted medical interventions that could save lives. So here's my question. When we talk about health disparities in indigenous populations, how much weight should we give to genetics versus environment and history? Leave your thoughts in the comments, because this is a debate happening right now in public health and genetics, and there's no consensus. But let's return to the story, because despite everything, the Chamorros survived. And their survival tells us something profound about identity, genetics, and resilience. When the Spanish arrived, they tried to erase Chamorro culture. They banned traditional religion, forced conversions to Christianity, outlawed cultural practices, and relocated populations to centralize control. When the Americans took over in 1898, they imposed English, suppressed the Chamorro language, and treated the islands as strategic military assets rather than homelands of a living people. During World War II, the Japanese occupied Guam and subjected Chamorros to brutal treatment, forced labor, executions, and starvation. After the war, the U.S. military took over vast portions of the island for bases, displacing Chamorro families from their ancestral lands. Through all of this, the Chamorros were told, explicitly and implicitly, that their identity didn't matter, that they should assimilate, modernize, become American, that their history was irrelevant. But their DNA told a different story. Despite centuries of colonization, despite population collapse, despite forced mixing and cultural suppression, the maternal line remained overwhelmingly indigenous. Modern genetic studies show that over 85% of Chamorros carry indigenous mtDNA haplogroups. The paternal lineages changed. Spanish, Filipino, American, and Japanese Y chromosomes entered the population through intermarriage and other means. But the maternal lineages persisted. Why? Because Chamorro society was matrilineal. Identity passed through the mother. When Chamorro women married outsiders, their children were still considered Chamorro. The matrilineal clans absorbed the outsiders rather than being absorbed by them. This social structure, rooted in ancient tradition, became a biological shield that preserved genetic and cultural identity through centuries of colonization. The mothers who never left, the women who stayed on the islands and passed their lineages to their children, maintained an unbroken thread connecting modern Chamorros to the voyagers who first reached the Marianas 3,500 years ago. And that thread is still intact. In 2023, scientists confirmed through ancient DNA analysis that modern Chamorros are directly descended from the original settlers. The genetic continuity is unambiguous. The Chamorro motif present in ancient remains is present in modern Chamorros. The linguistic connection to the Philippines, evident in the Chamorro language, is confirmed by genetics. The story the Chamorros told about themselves, that they were the indigenous people of the Marianas, that their ancestors had always been there, was true. Colonial historians questioned it. Anthropologists proposed alternative theories, but the DNA proved the Chamorros were right about their own history. And that matters, because for too long, indigenous histories were dismissed as myths when they contradicted European narratives. But genetics is now vindicating indigenous knowledge again and again. The Chamorros knew who they were. Science finally caught up. So what is the Chamorro mystery? It's the question of how a people made an impossible journey to islands no one should have reached. It's the question of how they survived 2,000 years of isolation and became genetically and culturally unique. It's the question of how they endured population collapse, colonization, warfare, and cultural suppression, yet preserve their identity, and the answer is written in their DNA, the maternal lineage that passed through 3,500 years, 140 generations. From the first women who stepped onto those islands to the Chamorro women alive today, governments changed, languages shifted, religions replaced each other, empires came and went, but the mothers who never left stayed, and they passed their genes, their stories, and their identity forward through the only mechanism that colonialism couldn't fully control: birth. This is what colonial history couldn't explain. It could document the wars, the forced conversions, the population collapse, but it couldn't explain why the Chamorros didn't disappear, why their genetic signature remained distinct, why their identity persisted when every force in history tried to erase it. The answer is in the mitochondrial DNA, in the matrilineal clans, in the women who refused to let their lineage end. If you found this story fascinating, share it with anyone interested in the hidden histories that genetics is now revealing. Have you ever discovered something about your ancestry that contradicted the official history you were taught? Do you think genetics should play a bigger role in understanding indigenous histories? Or does it risk reducing complex identities to biology? Leave your thoughts in the comments. The Chamorros crossed an ocean no one should have crossed. They survived a catastrophe that should have erased them, and they preserved an identity that colonial history tried to explain away but never could. Their story isn't over. It's still being written in the genes of every Chamorro alive today, carrying forward a thread that stretches back to the very first humans who dared to sail into the unknown. I'll see you in the next video. Thanks for watching.